No, I'll just hold on to them for now. Hi guys, I'm Brandon, if you don't know me. And let's just start off this morning with a quick check-in. So we're just going to go around the room, say one word to describe your break. All right, think about it for like 10 seconds. Your break. You just had like a 2-week break. So one word to describe your whole break. Are you good? All right. Let's go this way and go snake around. Yeah. Cool?
Tired. Good. 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 Sleep. Uterus.
Yeah.
Chill. Sleep. One word to describe your break. Cool. Cool. Yeah. Fun. Was it? Great. School. I have school, guys. I have break. I feel tired at school. But school's almost done. Huh? 3rd year. So, all right. So today, I will try to make this lesson as exciting as I can for you guys. Try to make it not I don't know what you normally do. And in return, all I ask is for your focus and energy. It's only for 1 hour, guys, so just bear with me as much as you can. All right? Sound good?
Yep.
All right. How many of you know this game? Yeah? Some of you? Yes? All right. Does one of you want to come up and kind of the game? Go for it.
I never played it.
Oh, why did I do this?
I will.
All right. So, who has never seen this game before in their lives? No? All right. So, what was your name again? Mercedes. Can you kind of do a quick demo on the projector and explain what's happening while you're doing so?
Explain.
Yeah. So just...
Use the power.
That's how you fly, y'all. No, that's it. And you gotta get all the coins.
Man, this game was 99 cents.
No, it's free. All right, so, yeah, as Mercedes was saying, there are coins, right, and there are obstacles. And your goal is to avoid the obstacles, get the coins, avoid the bullets, too. And whenever she presses the screen, what happens? It flies, right? The jetpack starts shooting, right? And then he goes up. Oh, all right. Hey, thanks. That helped. All right, thank you, Mercedes. All right, so that was just a very quick demo of what this game was. Now, I want to show a video of a playthrough that I recorded. All right. So I did this a few days ago. All right. Now, while you are watching this, can someone explain or tell me when am I touching the screen? Now. Right there? How do you know that? Can someone like raise their hand and tell me?
The things go down.
Yeah, exactly. The bullets are shooting, right? That's how you know that the finger's being touching the screen, right? All right. Yeah, that's pretty much it. And that's how you kill everybody. Exactly. Where's my mouse? Oh, there it is. Whoops. Yee. All right. All right, so let's pretend now that this is the graph of the person in the game, right? So like you started off here, and then like you went up, and it went down, up, down, again. Can someone raise their hand and give an answer for when do they think the screen is touched?
When it goes up.
When it goes up, okay. The mid?
Yeah, like when it goes right before it goes from down to up.
Right here, you're saying? Okay, okay. So we have when it's going up,
Well, the beginning,
and
and then yeah, it's correct.
the beginning of when it's going up, and then you say the mid right before it goes up?
Yeah, right before it starts to go up.
All right. Is there anyone else? Yeah. When the slope is positive. Good thinking. Yeah. So that's kind of rephrasing what he said, right? Because he said when it's going up, and when it's going up, right, the derivative is positive, right? Anything else? No? All right. Take a look at this graph. So what, Gianni?
Yes.
Gianni, yeah. So what you were saying is you're saying number 1, right? Being right before here.
Maybe 1 or 3.
1 or 3? 1 or 3? All right. Which numbers do you think is when the screen's being touched?
1, 3, 5. 5. Yeah, 5, 6.
6.
Maybe 4. It's like being like that.
Yeah. Yeah, exactly. Can someone explain what's happening with number 4 also? It's constant, right? But there's gravity, right? The gravity's always pulling the guy down, right? So how can we keep it constant this way? You tap it, right? You make sure that he has enough acceleration going up to make sure it's counteracting gravity, right? Yeah. Exactly. Yeah, this might be like one of the coin fields, right? And so you want to keep it constant to get all these coins right here, right? Yeah. What about that? What other things do you see in the game that might be reflected in this graph? Anyone?
The little laser things that you can't touch.
Yeah, the laser thing. So that might be like here, right? So you have to like go over the laser thing, right? Yeah, or under it. So maybe here. Yeah. Perfect. Cool. Any other comments about this graph? Anyone else have anywhere else they'd like to point out where the screen was touched? No? All right. Gianni, can you explain again why you think it's being pressed at 1? Because, so what was your name again? Mia? So what you were saying is you said you were touching the screen when the slope was positive, right? When it's going up. But here, what's the slope, everyone? It's negative, right? So why do you think you're pressing the screen at 1?
Because when you press it at 1, it's starting to go down. You touch it, and it has to change to go up.
Yeah, exactly.
Direction.
Exactly. Let's look at this for a whoa, hello. Ah, okay. Let's see it again right here. All right. So if we go frame by frame, all right, he's falling. All right. What about there? What just happened? Acceleration, change in direction, but more like with the game. You press the screen, right? And how do you know that? Because it started shooting bullets, right? So see right here, no bullets, right? Bullets, no bullets, bullets, no bullets. I could have picked bubbles, but we're using bullets for now. So this is where the screen was touched, right? But look at it the next couple of frames. See, he's still going down. You see that? So this kind of shows what Gianna was saying before, that you have to press the screen right before he goes back up, right? Because you're pressing the screen starting here, but you keep going down for just a little bit before you go back up, right? And that's to counteract the speed going down. Does it make sense to everybody? Yes? All right. Cool. All right, let's go back to here. Okay. All right, so for the next most of class, we're going to go over this worksheet. And you can read someone want to read the directions out loud? Yeah, go for it. Good, good. Can someone explain what's the difference between these functions? Yeah.
The first one is the original, and the second one is the derivative of the original.
And then what's this one?
Derivative of the derivative. Yeah.
Derivative of the derivative, right? The second derivative, right? First derivative, second derivative. Right. And how do these functions relate to this graph over here? Someone we haven't heard from before. Chris, what's the relationship between these functions and that graph?
Not sure.
Not sure. Can someone help out Chris? No? Okay, so these functions actually correspond with these graphs, right? So the black function here corresponds with the black graph there. The red one corresponds with the red one there, and the blue one corresponds with the blue one there. All right, everyone see that? All right, so this is what you'll be working on, bless you. And what I want you guys to do in your pairs, I'm going to pass these out, is find any patterns you see. Mathematical, artistic, visual, just anything you can find. The more patterns we can find, the more connections, the better, all right? So this is what you'll be doing in pairs, and as a class, we will be gathering together everybody's, and hopefully we'll have a huge list of everything that's going on, all right? And then there's another one below it. Okay. All right, so you can go ahead and get started. The graphs are not colored on the worksheet. I will zoom out on the PDF and show you guys the colors. Got that. All right, so once you get your papers, go ahead and get started.
So why is he saying one data source? You got an extra.
Oh, okay, thank you. Oh, I am so sorry about that. It's just you guys?
Well,
Yeah, so since you guys don't have colors, maybe the first thing you want to do is write down which of the lines, which of the graphs are each function. Or if you have highlighters, that works too. Go ahead and highlight it if you want. You guys know what's happening?
This one is going to be a line.
Mm-hmm.
Versus this one.
Yeah. How do you know that one?
Well, guessing, I'm pretty sure that this, if you reduce it or take the 6x out, it's going to be like x minus.
Mm-hmm. Yeah. So actually, I had the colors up here. You can't really see it, but the black one on top corresponds with the black graph, and the red one's the red one, and the blue one's the blue one. Yeah, so you don't have to guess which function goes with which graph.
Okay.
So actually, this one goes with this one.
Okay.
This one goes with that one. This one goes with this squiggly one. Yeah. So let's look at that if you need any help. Yeah, just more broadly, what you guys are doing, just look at the relationships between the different graphs or the different functions. So for example, like you see at 0, right? This parabola is here, the curvy one is here, and the straight one is there, right? What do those values mean? Or like, where do you see like, so this one's straight, and this one's like curved. What's the relationship between that? Like, what's happening in that? Yeah, just find anything you can. Yeah, if you need more help, raise your hand, let me know. or maybe ask the group behind you. And yeah, for sure. Thanks, guys. Oh, one last thing, you guys have until 11 to do this. So, yeah, find as many as you can in 15 minutes. Oh, you need help? Anything? All right, cool. Yeah.
One example of like a connection you could make.
Okay. So, just really quickly,
A lot of you are struggling to get started on this. Can I get everyone's attention, please? All right. Just really quickly to get started, let's talk about what we did last time. So before break, what did you guys learn? Does anyone remember? I found first derivative and second derivative, right? Do you guys remember the first derivative test? Yeah. Can someone explain what that is? Andrea? Where's Andrea?
Right here.
Oh, there.
It's when you have to find the derivative and then you have to see where it's increasing.
Yeah. So you find the derivative, and more specifically, when the derivative is positive, it means the slope is going up, right? If the derivative is negative, the slope is going down.
and if it goes from positive to negative, what does that mean? Does anyone remember? It's a max, right? When the derivative goes up and then it goes back down, it's a maximum, right? If it goes down and goes back up, it's a minimum, right? So for example, you can see that with the red graph and the black graph, right? The red graph is the derivative of the black graph, right? So here, it's positive here, right? It's negative here, and it switches right here, right? That's when it's 0. And you can see here, this is the peak. That's the maximum of the original graph, right? You can see here, the derivative is positive, and it's increasing here. It's negative here, and it's decreasing here. And right here where it's 0 is where the peak is. Does everyone see that?
Yeah.
Yes? Sorry? The peak is the max, right. All right, let's just get a show of hands. 1 to 5, how clear is this? How weird is this? 1 to 5, raise your hands. Oh, sorry, 5 being good. You're solid with this. 1 being I'm not too sure about what's happening. 1 to 5. All right. No. All right. Those of you who feel solid about it, those of you who feel comfortable about it, go ahead and get started. Keep finding other connections. I'll go around and help everyone else who's still struggling with this. Is me in the bathroom? Okay. What can I help with?
Like, what kind of connection like this? I don't understand what you mean by connection.
So by connections, I mean like patterns, right? So for example, what I said before about when the derivative is 0, the original function is at its peak, right? That's a connection. 0, peak, right? So try to find other connections between these 3 graphs and see what other things can I find. You know, when the second derivative is 0, what happens to the first derivative? What happens in the original function? Stuff like that. Does that make a little bit more sense? All right, cool. All right. Is there anything I can help with?
mean, I understand what to do. I just like trying to figure out how should we show the connections or like what we notice about them. 'Cause, like, I can see some stuff I noticed, but how do you want me to confused on how I should show it, how to show it?
Well, give me an example. One thing you notice. Has the area? Can you explain that a little more?
Like the space they have, they all intersect as an area.
Yeah, they all intersect. So you're saying there's like a space where they're like between graphs? Yeah, that's definitely one. I mean, yeah, we're literally finding anything you can find. As many things as you can get. Yeah, go for it. So what you're saying before about like not knowing how to show it, just write down whatever you see. Yeah, anything. It doesn't have to be math related either. You could be like, oh, the curve is pretty. Like that could be one thing too, if that floats your boat. But yeah, anything you find, guys, go for it.
You know what I'm saying? But it's increasing, it's positive. When it was decreasing here, the derivative was what? Does that make sense?
What is the learning objective? Just about the second derivative?
Huh?
Yeah.
5e? Yes. I can send it to you right now. What's your email?
I don't know why I put algebra 1.
You're right here. Lowercase. That's a U. I don't know if this is any better. That's an R.
Yeah. Gmail?
Yeah.
Okay.
Next thing you know, you go to percent. You get the cafeteria. I was like, wait a minute. You're fun there. Next thing you know, you guys magically meet up in some community college, just sitting there
I wouldn't be surprised if I
it's like, wait, Chris,
Did you get that?
No, it's. Oh, I'm sorry. I didn't even check. My bad. There's nothing wrong with your lesson. I no, I did that.
No.
last day of school, drops out. Everyone says that it's better jokes. If you drop out, you still graduate because you finish everything and just get that one out.
Unless it's like, hey, if you don't come. We think about y'all.
Hey guys, can you focus on your own groups, please? Yeah. Just for 10 more minutes. All right. What kind of things have you guys found?
We found
When it's positive, it's increasing. When it's negative, it's decreasing.
Okay. What about the second derivative? So look at for the second derivative. When the second derivative is positive or negative, what happens to the first derivative and what happens to the original? Can you look at that for me? Yeah. Go for it. All right. What don't you understand?
I don't understand. Like, I know we're supposed to look at the original to see the connection between these two and when it connects to the original one, but I don't understand what you mean by like connection.
All right. Yeah. So can you tell me what did you understand what I showed up there, or were you still kind of? Okay. So what I did was show. Nah, it's all good. So this curvy thing's the original graph, right?
Yeah.
And the parabola is the first derivative?
Yeah.
Right, so when the first derivative is 0, what's happening to the original graph?
It's curving.
It's curving, right, but more specifically, when it's exactly 0, what's happening to the original graph?
It's at 0.
It's not at 0, no, it's a little bit above.
I don't know. It's at the top?
It's at the top. Yeah, that's the big part. So when it's 0 here, it's at the top, because what? When it's positive here, right, it's increasing, and when it goes to negative, it's decreasing. Right? So when it's 0, it means it's at the top, right? Right before it's increasing, it's decreasing, right? So that is an example of a connection. So what I mean by connection is like any patterns, things you find between the two graphs. So what I just did with the first derivative in the original graph, do the same thing with the second derivative, and the two graphs, and any other patterns you can find. Doesn't even have to be math related, just literally anything you can find. We're trying to get a lot of things that everyone found. But yeah.
Thank you.
Can you guys turn around, please? Yeah. It's just 5 more minutes, and then
Here, look.
we'll get together soon.
If you notice on this part, the means of this
Cool. What'd you guys find in the first one?
The intersect points located below the x-axis. Like if you circled it, all their regions, they kind of almost below the x-axis. And they all increase as you go across left to right. I was trying to see the difference because I see that they're undergoing some type of double derivative, triple derivative, some double derivative.
Yeah.
I'm trying to see how that relates, how these relate to the way the graph look over time, like why do they do that?
That's good. Yeah. What about the second question? Did you guys find any connections for that one?
Right here?
Yeah.
It seems to be like almost a mirror opposite.
Yeah. Yeah, that's definitely one observation. Which ones are opposite?
The sine and cosine.
Sine and cosine?
And then something just seems to be like in the in-between room.
Yeah. Can you look, which one is... Okay, so this one's kind of confusing because it's like, they're both like squirrely. But the black one is this one, right? That's black. And which graph is black? Can you see?
Yeah. The graph is black is the middle. If you go 1, 2, 3, like the blue being the third one, the black is starting at the tip of the blue, right?
Okay, yeah.
The blue, black goes like that.
Yeah, so this is the
black,
black
yeah.
one, right there, that one. So can you just like mark that, like?
Yeah, I'm gonna
that
mark
one's,
it.
yeah. Yeah. So when Will gets back, all you guys will be doing is doing the exact same thing with this one. Just see what things transfer over to this problem. See what things are the same, what things are different, and yeah. Just keep going. I think you guys are doing a great job. So yeah, just keep doing second problem and you're good. Thank you.
My quads are gonna look so beautiful.
I didn't know that. I didn't know there's football field was. I'm really ridiculous. I think they're cute.
I know it's pretty small.
I was like pretty upset about it. And the next thing I know, he calls me. He's like screaming.
What was he screaming?
Alright, if you want to hear the story, so he's like screaming to me, and he's like freaking out, and I asked him like, "What's wrong, Brandon? Are you okay?" And he tells me that he got herpes because his girlfriend cheated on him. Well, now his ex-girlfriend cheated on him with another dude, and the dude gave her herpes. Wow. So now he has herpes.
That's pleasant.
Yeah, it's pretty hardcore. I feel bad for Brandon. He says it's like very itchy. And he says he can't have sex during a breakout. So yeah. But he says like breakouts happen like months, sometimes every other month, sometimes it takes like 6 months. So it's not bad. It's just not good though. He's like in pain and it's itchy.
Over time, I've heard that it gets little less uncomfortable because you get used to it. Unless if you get like treatment for it, you know.
But the thing is though, he's 19 and she's 18, so I'm pretty sure he can like do something about it, to like bring it to court or something. Because she didn't tell him that she cheated on him and that she got a transmitted disease.
Oh, well, that's true. Yeah.
So I don't know if you're able to do something about
I
it.
don't think the age has to do anything with it though. I mean, because they're both adults.
Yeah, I mean, I don't think the age has something to do with it. But I mean, if you give someone an STD, like you should be in trouble for that, especially if you don't tell a person. Like you should tell them, like I have issues, like I have a sexual STD, I have an STD, and like if you choose to have sex with me, you risk the chance of getting it.
Yeah.
I don't know, he was pissed off though, and he loved her too.
Yeah, that's really sad.
Can I cut you off right there and look back at this?
Well, I'm done.
You're done?
Yeah.
Can you find more things? I mean, are there only 3 things in the world that describe number 2?
He brought up that they intercept the x-axis 4 times. Yeah.
That's good. That's good. Can you find other things?
Other than that, I can't really find anything else.
Nothing?
But we're going to go over this as a class, right?
We are going to go over it as a class.
Cool. All right. Really?
All right.
What?
I didn't apply for anything.
All right. Does anyone need more time? Shh. Anyone need more time? Or are we all good? All right. How did this worksheet feel, guys? Was it good? Are you still kind of confused what's going on? Eyes up front, please. Thank you. All right. Where's my mouse? There's my mouse. All right. Can someone share what their pair found for... Why isn't this working? Can someone share what their pair found for number 1? What are some connections you guys found? Anyone? Kerwin?
What?
Can you share one thing that your group found for number 1?
We found that when it's positive, it goes up, it increases, and when it's negative, it decreases.
When what is positive, what is decreasing? Or what is increasing?
The first one is positive, it's increasing, and the second one is like negative, it's decreasing.
Are you talking about which ones is which?
The first one.
So like first question or
Right there.
this one?
Yeah.
All right, so this one, when it's positive?
No.
Do you want to come up and draw it on?
No.
No?
But the red one is
Yeah.
increasing.
The red one's increasing.
Yes.
Okay.
And then, yeah, that's what I found.
So the red one's increasing all the time?
It can be. It might be.
Look at the red one. Is it increasing all the time?
No, it's decreasing. When it goes down, it's increasing. When it goes back up.
Right.
So like on the 4, it goes increasing. So like in this 4.
On 4 it starts increasing? All right. Yeah. Can someone go off of that?
Fine.
Anyone else? Do you guys agree or disagree with that? Yeah. Yeah. Mm-hmm. Yeah, this is the minimum. Yeah. All right. Can we go off of that? So you said that this is the maximum, this one's the minimum, right? How do those two things show up in the red graph? Mia? Extremas.
The first one has 3, the second one only has 1, and the last one is numerous, so it's 0. It's just confusing.
Yeah. So which extremas did you find? So you said 3 for the original function?
No, just 2.
2. So which ones were this one? The minimum. Well, mm-hmm. Yeah. There's one here, and the linear function doesn't have any extremas, right? It goes negative infinity to positive infinity. Yeah. Extremas is maximum, minimum, right? So you have, this is a maximum, this is a minimum. Extrema is like both of those combined. Yeah. Sochi, did you want to add on to that? No? Spot on? All right, cool. Perfect. Again, I ask, how do these extremas show up in their derivatives? Yeah.
I think the x value where the extremas are,
Mm-hmm.
like the zeros for the parabola.
Good, yeah. So what was your name again? Vernice. What Vernice saw was, here's an extrema for the original graph. And like I said, it's when this is 0, right? The first derivative is 0. The extrema here happens when the first derivative is also 0, right? And now if we look at the red graph, this is the minimum. And the blue graph is the derivative for the red one, right? So the red extrema happens when the blue one is at 0, when the derivative is 0. Yeah, that's good. How about any connections between the second derivative and the original graph? So the blue one and the red one. Did any groups find that? Find connections? Shalia? Yeah. Did your group find anything connecting the blue and the black one? No? Right. Okay, that's good. Abner? No? Nothing? All right. Yeah, go for it.
The blue and the black ones are increasing overall.
Overall?
Yeah.
So you mean like when you keep going that way?
Yeah, when you keep going that way, in the end they're increasing.
Yeah, that's one observation, definitely. So as we keep going this way, the blue one's going up and the black one's going up. Yeah, that's good. Anything else? Let's do one more person. Mia, do you have anything? You did just say something. All right, well, just say one more. Who didn't say anything? He said something. Jonathan C? No? All right. Let's try the second one, maybe. Who got to the second problem? Did anyone get to the second one? Yeah, you two? Anyone else? You guys? All right. Just really quickly, can some of you guys just shout out something's happened in the second one? What observations did you guys find? It goes up and down. Good. Anything else? Will, what did your group find? Yeah, that's good. So the x-axis here could be thought of as like a mirror. Is that what you're saying? And then the black one and the blue one are mirrors, right? Yeah? It's good. Anything else? Yeah.
On the origin, like, they're all, like, equal to 0, so they're intersecting in 0.
What about the red one? The red one's not, right? But yeah, for sure. The blue and the black one are. Yeah. The blue and the black one are, and the red one is up, right? What about that? What? Yeah, go.
My partner and I, Andrea has said that when the red is at max and or min, the blue or black are always crossing the x-axis. They are equal to 0.
Nice, yeah. So one thing they noticed was whenever the red one was at the minimum or the maximum, the blue or the black ones were always at 0. Did anyone else find that? Who else saw that? You guys saw it. You guys saw it? Yeah? When they said that when the red one is at its like the lowest point or the highest point, the black and the blue one are at 0. Yeah. It's a good observation. Yeah. Anything else? Did you guys have something? No? Anyone? All right. Let's go back to this point. That was, Gianni, that was very good. But going back to this point, or actually, no, same point, yeah. All right. When the red one's at the peak, the blue and the black one are at 0. So the red one is the derivative for which function? Black or blue? Black. And the blue one is the derivative for which function? The red one, right? So let's look at just the red and the black one for now. So the red is the derivative, so the slope of the black one. And when is the first derivative positive or negative here? Positive, right? And you can see that the black one is increasing, right? That's what we learned about the first derivative. And what about here? This is positive or negative? Negative. And the black one is what? Increasing or decreasing? Decreasing, right. Let's look at the red and the blue one. Now, the blue one is the second derivative, right? The blue one's the derivative of this one. So everything that applies from this one to this one is the same for this one and this one. Does that make sense? Yeah? So we saw that when this was at its peak and it's positive, this one's increasing. And when this is negative, this is decreasing, right? The blue and the red one could be shown to be the same way, right? When the blue one's at the top, right, max, what is the red one at? Look at this thing. Right there. Red one when the blue is at the top? At 0. What about when the blue's at the bottom? Still at 0, right? But what's the difference, right? This here, it's positive, right? And so the red one is increasing or decreasing? Increasing. Here it's negative, so the red one's decreasing, right? What about the blue and the black graph? So as Will mentioned, they're like mirror images of each other, right? What do you see in the mathematical relationship between them? Yeah. Yeah, definitely. So when the blue's down here, the black one is up here. And the black one's down here, the blue one's up here. Right? Yeah. Anything else? Yeah? The inverse? They're inverses, right? Can you explain a little bit more on that? What do you mean by inverse? Yeah, that's good. Yeah, they're inverses, definitely. They're mirror images, right? All right. When the blue one is at its lowest, all right. Okay. Does anyone else have anything else on this question? Good? All right. For the last 5 minutes or so, we're just going to go over some more things on the slides. Yeah. All right, so for this example, let's say this is the first derivative. Can you guys help me with this? What would the first original graph look like? If this was the first derivative, what kind of things would we notice about the first original graph? It's squiggly? It's cubed, okay. Can you explain why you think it's cubed? Number 1 in that example. That's good, yeah. So when it's a straight line, she saw there was a straight line in the first question, right? And the first question had a cubic function, right? So there's a connection there. Anyone else? Who agrees with that? Who disagrees with that? Yeah. This is the first derivative. Yeah, exactly. We see the relationship between, doing integrals and the graphs we saw, right? If you have a linear function, right, something x plus something, right, this is going to, the antiderivative of this is going to be something x squared plus something x, right? So if this is the first derivative, then this is going to be the original, right? Antiderivative. All right, so exactly, what was your name again? Lisbeth. Lisbeth. So exactly what Elizabeth was saying. It's going to be a parabola, right? So the parabola is going to be like this or this, right? Which of you think it's this one? It's going to look like this one. Which one of you thinks it's going to be like this one? Okay. Those of you who said this one, why did you say this one? Yeah. What's positive? The derivative, right? So you're saying here's positive, right? And you're saying that because this is positive, it needs to be increasing? Yeah, that's good. Why might you guys think anyone might choose the second one? So like none of you voted for this one, right? Why did you not vote for it?
Because it doesn't have any trigonometry in it, so it's not like the sine and cosine. It doesn't eventually flip back to the inverse. It doesn't go like that. So
Yeah. Okay. Okay. Why might a student who's not as smart as your class choose this one instead of this one? Are there any reasons why a student might choose this one? No? I mean, maybe one thing could be like, oh, it's increasing and this like has a peak. Maybe that might be one thing. Is that what you're going to say?
Yeah, I was going to say, like, in the beginning, from left to right, the parabola on the right, it increases.
Yeah.
So they thought maybe, since this increases from left to right, so does that one. So
Yeah. Perfect. That's great. Yeah. Anything else? No? All right. Okay, so yeah, you're right. It's this one. And every parabola has the lowest peak, right? You guys chose this one, so it's the lowest one. Where do you guys think the bottom point, the vertex, is going to be on the graph? Yeah. At 2. Why? Yeah, the x-intercept, right? When x is 0, or when y is 0, across the x-axis. Right, so it's going to be something like this, right? And you guys can see how this works, because over here it's positive, so it's going to be increasing, right? Like most of you said. And then when it's negative here, it's going to be decreasing here, right? All right, what about if this was the second derivative? What might this look like? This was the second derivative. So if this was a blue graph, right, what would the black graph look like? The parabola would be the first derivative, right? And the line would be the second derivative? Is that what you're saying? Oh, sorry. The line. Yeah. All right, so this would be very similar to your first. Right, the squiggly. Right. Exactly like that. And we'll go more into this later. But yeah, thanks, guys.
Squared to like linear, and then right here in this one, was this the first derivative?
So the first thing we talked about was if this was the first derivative.
Okay.
So
and
this
the
was
parabola
red.
would be the second one, and then it'd go down to cubic.
Yeah. So that's going antiderivative. So we're kind of like working backwards.